Hi guys, this is AP Chemistry, topic 9.10, electrolysis and Faraday's law. The objective for today is to calculate the amount of charge flow based on changes in the amounts of reactants and products in an electrochemical cell. So this should be hopefully a review from physics. So current is defined as the amount of charge transferred over time. I equals Q over T. Because electrons are the carrier of charge, the current is related to the amounts of reactants or products in an electrochemical cell through some stoichiometry. Again, so in essence, the goal is to apply stoich to electrochemistry. So some things to know: 1 ampere equals 1 coulomb per second. Faraday's constant, F, relates coulombs and moles. So Faraday, or the capital F constant, 96,485 coulombs per mole of electrons. These two relationships you're going to use, you can see how you can use this actually with some stoich. So, yeah. All right. So here's a generic example. Gold can be plated out of a solution containing Au3 plus according to this half reaction. Au3 plus aqueous plus 3 electrons produces Au gold, solid gold. What mass of gold is plated by 20 minutes flow of a 5.5 ampere current? So it's kind of crazy that we're kind of implementing some physics into our AP Chem class. So before we start, you need to know what you need to use. So because we have coulombs, we have amperes and all that. So ampere is coulomb per second. We have minutes, so we have to convert our minutes to seconds, convert our seconds to coulombs, and from there you can convert your coulombs to moles of electrons with your F, and then from there, if you can use some stoich, and then the molar mass or the atomic mass of gold in the end, which is kind of crazy. It kind of blows my mind actually, not gonna lie. So this is a little more broken down. So we convert 20 minutes to seconds. From there, our minutes cancel out, and we're going to be in coulombs by using our current amperes or coulombs per second. From there, we convert coulombs to moles with Faraday's constant. From there, we convert how many moles are transferred to the moles of gold, solid gold in this, because we're talking about plating. Then from there, convert moles of gold to the mass of gold. Again, kind of blows my mind, I'm not gonna lie. So this again can be used in other ways. So you can look at, say, if you want to reduce 0.25 moles of copper 2 plus to copper, solid copper in 1 hour, what current would be needed? So we convert hours to seconds because in the end, we want to figure out how many amps because we're asking for the current. Your current, remember, the unit is amp, so that's going to be coulombs per second. But before we get there, we would start off with 0.25 moles of copper and convert that to how many moles of electrons? And then multiply that by Faraday's constant, because that now will give us coulombs on top, but we want seconds, so we just got to divide by the seconds to get the amperes. Calculate the charge transferred in a reaction that uses 2.5 amperes for 5 minutes. So let's see. We know that current is coulombs over time, or charge over time, I'm sorry, but we want to figure out the charge. So it's going to be current times time equals, let's do that, equals Q, charge. So it's amperes times seconds, because remember that your current is coulombs per second. So it's going to be 2.5 amperes or coulombs per second times my time that's going to be in seconds. So I have 5 minutes. Convert that to seconds. Oops, 60 seconds per 1 minute. So now my minutes cancel out, so do my seconds. I'll end up with coulombs for this. So it's going to be approximately 750 coulombs. Yeah, spelled right good. Tin is used as a cathode in the following chemical reaction. SN2 plus 2 electrons makes solid tin. So if 1.34 grams of tin is plated onto the electrode over 75 seconds, what current must have been used? So remember that I'm trying to find current. So current is Q over T. So I want to get my coulombs. So I'm going to, I have 75 seconds already, so that's easy. Oops, chihuahuas. Okay, 75. Oops. So I'm going to convert my grams over to coulombs. 1.34 grams of tin. So 1 mole of tin is 118.7 grams of tin. So now I'm in moles of tin. I got to get out. I'm going to use some stoic, kind of a mole to mole-ish ratio. So I have 1 mole of tin. That means I have 2 moles of electrons. In 1 mole of electron, I have 96,485 coulombs. So this answer I get here, I'm going to plug this into my numerator. So this is going to be 2,000 or 2178 coulombs. Divide that by seconds, 75 seconds. I will end up with 29 amperes. All right, guys. So if you have any questions, please let me know. Thanks.